easily be built at our universities, in our national labs and everything, and then settle this argument once and for all. All you got to do is do state-of-the-art efficiency in the switching. Don't try to use too strong a current to begin with. Use a very small trickle current. All you want is that field at that short period of time when you have transit through the back MMF zone. That's all you want.
It's timing.
Timing is everything. You have to pay for the timing and the switching. You don't have to pay for the energy. If there's one law we need to pound in every engineer's head, you have to pay for timing and switching. You don't have to pay for the energy. That's nonsense. The energy comes right straight out of the vacuum for free from all the charges. So that's one engine that we wanted to discuss that could be built by any craft shop, any outfit that builds motors and generators could easily build it with their own staff and workers that they already have. They would have to think a little differently, just a tiny bit differently.
Is that the same as the magnetic Wankel engine?
Yes, that's the magnetic Wankel engine. They actually put that engine one time in a Wankel car.
It just proves the principle that it can fire into the track, see? So there's the pole. And then there's, see, that acceleration that takes place in the magnets. Like this, see? It goes around there for free, but then comes by and triggers itself again, see? Watch. See it?
Right.
And then down here is a dead spot, see?
Why didn't you run the magnets all the way around?
Because we just wanted to see if it would accelerate through the track.
Okay.
We just wanted to experimentally see that it would run
So by just
and do what they said it would. And it does. Of course, you get much finer with this, right? You get real finer in detail with this and make the pole piece bigger and the magnets closer together, and then the thing would fly. I mean, because it goes now. It's just a model to prove that the theory worked.
and so you just you were satisfied with that, so you just quit.
Well, I couldn't do anything with it. It's a patented item, you know. I can make one,
Right.
but you can't sell them.
Yeah, I think it hasn't patent expired now.
I don't know.
Yeah. When did you build this?
When I put the pages up on the internet, when was that?
That-
96.
96?
Yeah, I wanted to see, you know, I was working with some magnets and I wanted to see if that track theory worked,
Right.
and it does.
So if you ran the magnets all the way around, it would run.
It would run like the magnetic Wankel.
Right.
But I didn't want to make it too
Because
obvious.
you've disconnected. Yeah.
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 I didn't want to make it too obvious.
I see. You wanted to stay this side of the patent.
Yeah.
Yeah. Right.
It's not mine, so
Yeah.
I want to stay away from it.
Yeah. Hitachi had. Hitachi had. They had a scooter or something.
The reason it's not on the market is because the Japanese Yakuza has suppressed the Japanese engines that are over Unity off the market, including the Kawai engine, which was suppressed here in Huntsville, Alabama, directly in front of my eyes and directly in front of the people that I work with, my associates here. We have plenty of witnesses as to when Kawai's engine was seized and when control of his company and his fate was seized by the Japanese Yakuza, looking at us across the table. So this is not hearsay. This is something we absolutely experienced ourselves personally, and multiple people did.
Mr. Kawai.
This is the Kawai engine. We had just reached an agreement with Kawai, and Kawai does another trick that switches the back MMF path into a forward MMF. He switches the path. And if you apply the Kawai process to a high efficiency magnetic motor, for example, a Hitachi motor, you can get one at 0.7 or 0.8 efficiency. The COP will be about double the efficiency. So you'll get 1.4 and 1.6 for your COPs. Again, totally consistent with physics and thermodynamics, nothing magical at all. Had his system and company and everything not been seized, we would have had, that was 96, we would have had Kawai engines worldwide on the market in 1997. And that's what stopped it, and that's what's stopping it today. So there are systems which work. If you wanted to do work on the Kawai engine, it works just like what he put in the patent. if you will carefully do the patent and use state-of-the-art switching, photon-coupled switching, you can build a Kawai engine, and if you'll start with a high-efficiency motor instead of a low-efficiency motor like we commonly have, you can have a motor that will go over unity. Kawai already had one with positive feedback to run itself. That's the one we would have put on the market. So that's another one that anybody wants to build something absolutely legitimate. If you will take the time and the trouble and do it state-of-the-art switching, you can do it with the Kawai motor just as it's stated in the patent. There's nothing false in that patent. Another engine I'd like to talk about is a permanent magnet motor altogether, without any switching or without any trickle currents or anything. Now, let's reason together. If I'm going to violate this second law of thermodynamics, I'm going to have an extra input of energy from the environment. If the only energy going into the system is what I pay to put in, that system is never going over unity, because it's got losses. I'm back in leaky diode engineering. I'll put in some, leak out some along the way, I'll get out less than what I put in. As simple as that. If I'm going over unity and all I have available is leaky diodes, I have to have something else putting in energy. What it turns the diode into a triode. I'm paying for the grid signal and something else is putting in most of the energy. So understand very clearly, we cannot do this unless we receive in these permanent magnets an extra pulse of energy for free from the environment. So how can we do that? All I've got is permanent magnets. Where's the energy going to come from? Well, nature has been most kind. In magnetism, there are some 200 or so known magnetic effects. Well known, in a textbook, in a handbooks, you can go look at them. But only about 100 or so of them are well understood. The other 100 vary from somewhat understood to not understood at all. I want that to be clear. Magnetism has many areas that are still not well understood at all. Many times just an ad hoc theory. So, but there are lots and lots of rich effects in magnetism if you dig them out and look at them out of the magnetic materials handbooks. One of these is the exchange force. Go into Feynman's 3 volumes of physics and read what he says about exchange forces, for goodness sake. The magnetic materials themselves can undergo a sudden flip of the spins of the electrons. And that is a sudden magnetic field pulse, because the spins have to do with the magnetic spin in the magnetic field. Isn't that interesting? Long before we had what today we're calling spintronics, where we are actually using these spins and beginning to build semiconductors and things that do spin flipping, people like Howard Johnson and people that doing experiments with the exchange forces were doing it a long time ago. Howard Johnson was working in what today is called spintronics 50 years ago, before that word was ever even born. But he was chasing and getting the spins to flip. So let's build a permanent magnet motor first that won't run itself, and then let's make it into one that will run itself. Wouldn't that be interesting? So what we do, we use the rotor and the stator, and I'm going to use in my rotors, I'm going to use north poles on all the poles that are there. And in my stator, around the outside that's fixed, I'm going to use south poles. So let's take one pair of these poles with the rotor north pole coming into the south pole. Now, I'm in the forward MMF position, am I not? This thing is attracting it in, and so it's adding to the angular momentum of the shaft, and this thing is picking up energy storage all the time, till the poles now actually oppose. Well and good, I got a lot of energy that nature gave me that I didn't have to pay that's now stored in my system. However, as it continues to rotate, if I don't change anything, I pay back every bit that I gained, because I entered the back MMF where it's trying to pull it back in the other rotation direction. And it subtracts back all of the energy it gave me for storage. I pay back everything. And since I got some other losses from the bearing frictions and fighting the wind, the air, to actually turn in it against the wind, against the force, I have losses. So this system will not self-rotate. I can give it a big spin to begin with, and it'll flip around a few times, and it'll run down, and it'll stop. That's it. Well known, no problem. So what's new? And what's wrong with that? How am I going to make that self-rotate, taking its energy from the vacuum? Well, I've got to follow my basic principle. If I want that to self-rotate, I'm going to have something which injects some extra energy. And if it's pulse form, that's better, because that gets under the thermodynamics that's known to violate the second law, already accepted. So I need some pulse inputs, a powerful pulse, to get a good bit of energy in that thing so I can have enough left to overcome my wind resistance I'm paying for and my friction in my bearings. Can I do that? Yes, indeed. The exchange force will do that for you. What Howard Johnson did was find complex assemblies of magnets, little magnets that he cut in special forms and shapes and all of this. And over years, he found how to put together sets of these, so that just as he has a rotor magnet passing the stator magnet in attractive mode, just as it enters that back MMF mode where it's payback time, the stator magnet will suddenly, the materials themselves will suddenly generate a spin flip the spins, and that will generate a very powerful pulse. And you've got to get it in the direction you want it on the other magnet so that it adds to the rotation. So it's tricky to do that, and it took him a long time to discover just how to do that, and just how to cut those magnets, and just what kind of magnets, and all of that. But he eventually solved the problem of how to do that. Now, if you will check Feynman's 3 volumes, you will find that this sudden force that occurs for the exchange force can be hundreds of times stronger than the magnetic fields and the magnets you're using, momentarily. But it can be a very powerful pulse. Johnson developed a series of magnetic gates and rotors passing stators and so forth, where the exchange force is in fact evoked. The pulse goes in, you get enough of it in the right direction to kill again the back MMF section, overcome it, and produce a forward MMF section. You need it just for a little bit till you get out of the back MMF. Then you're okay. Because if my back MMF is now decreased, less than my forward MMF, and if I don't lose too much losses in my system, that system will power itself and self-rotate and power load. And that's true. And you didn't violate a single law of physics, and you did not violate thermodynamics once you include the broken symmetry of the dipole and where the energy is coming from.
Now, does that pulse have an electrical switcher on it, or is it all just...
No, it's just the electrons themselves that are making the magnetism just suddenly flip. And that's the spin of the electron flips, and that's a tremendous pulse when it does.
So the timing is also...
Timing is critical. The timing is what is the most critical thing on it. And everything physically that you do to this assemblies of magnets affects that timing. That is, what the material is made of, exactly the shapes that you put together, and it's going to determine which way the pulse goes, and getting it to occur at exactly that right time. See, he's doing it all mechanically. He doesn't have any switching.
There's no electronics.
It's the assembly that determines the switching. So that's very precise work and very intricate work to do that. But it's a doable. It is certainly a doable. But you've got to be very precise and have good machine precision in the way you make your magnets, and you got to pay the penalty to find out how to do all that. But once you evoke the exchange force by whatever means, you can use spintronics to do it now. By whatever means you evoke the exchange force, you can in fact have the materials themselves take from the vacuum extra energy and give you a tremendous pulse of energy that adds that energy you need to your system and overcomes that back MMF. And that system will then permissibly power itself and power load, taking the energy from the vacuum by its fundamental dipolarity, its fundamental broken symmetry in that vacuum flux. Everything is good physics. There's no hokum, there's no sleight of hand, there's no magician's trick or anything. There's pure science behind it. Doesn't mean it's easy in that case, but it can be done.
You could essentially build the equivalent of a hydroelectric dam.
That's correct.
In the middle of a desert.
That's correct.
Because it's all magnetics.
That's right.
You don't need any external power. You don't need, it's all timing and natural magnetic forces.
That's right. Many years ago, when Howard first made his first rotary engine, Howard brought it down to Huntsville to show me. That was in the 70s. And we sat in my kitchen, and I played with this thing for 2 or 3 hours, just fascinated by it. There wasn't anything in it but permanent magnets, and it just sat there and it ka-clonked. It was part of it was crudely made. It just went ka-clonkety, 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 and it kept right on going. Now, if something will run 2 hours, ka-clonkety, ka-clonkety, and there's nothing in it but permanent magnets, and it's got that much drag, the bearings weren't even good. He was using an old Lazy Susan, which poor bearings, wasn't precision bearings at all. He just grabbed something and put the magnets he found that would work on. So there was no question about the reality of it. The question then was, how do you explain it? But Johnson knew about the exchange force. He knew exactly what he was trying to do. So Johnson was on, in fact, the proper scientific track that is permitted to build a self-rotating, self-powering magnetic engine. Permanent magnets only.
Did he learn this from observation?
Johnson started working in magnets. See, Johnson's in his 80s right now. As a young engineer and everything, he used to work for, I believe it was Chrysler. He did the magnetic brakes for Chrysler way back there. Johnson did some very unique things. He was a specialist in silencers, for example. There's a lot of patents in silencers back there.
For guns?
How to silence things that make racket. Johnson silenced a locomotive one time. Cut that noise way down to where if you were a certain distance from it, you didn't hear the locomotive. He could silence a chainsaw pretty good. Things like that. So he had some very unique things he had to do in his engineering experience. But he was a specialist in that kind of thing, and he started off working in the magnetics. He read up everything that he could find about the effects in magnetic materials. So Johnson got on to the spin and spin flipping very early, when very few people knew about it at all. It was an idle curiosity in a few lines in the text somewhere. We didn't have what today is trying to be born as spintronics. Now we're trying to create a whole science based on just spin flipping. Johnson has been working in spin flipping for 50 years. Very fine individual, I might add. He's a very fine human being. I'm very proud of the fact and very grateful that I was permitted to work with Johnson and have been for many years, still working with him today. I got into this kind of thing because first was an interest in strange weapons that I ran into the Soviets were building when I was working in that area. And then that led me into energy, because the problem that we ran into with trying to figure out what these Soviet weapons were, they were not using normal electrical engineering. They had modified it into a science they called energetics, which was highly classified, and they never have released it really to this day. What they really did is correct all the errors in the model. And when you do that, you can do all kinds of things that we've discussed a little bit that you can't do with normal, much more limited electrical engineering. So they were able to build very special weapons using that, but it has beautiful applications in medical and in energy fields. So, you know, it's a perfectly legitimate science if we take the old electrical models we have and change them and update them by what we've learned from physics. We will have then what the Soviets have been, the Russians today have been calling energetics for a long time. And we can do some marvelously beneficial things for human beings with that. One of it is in the energy field, and the other particularly is in the medical field. So that got me into the energy field. And then I started working with inventors. I started working early on with Frank Golden, and we talked about building the motor that kept adapting its environment and gradually got up over unity. And we didn't understand the mechanism going on at all, but it did get up to the performance, rigorous measurements. So that was very interesting. But again, I was fortunate to be able to work with an inventor who was actually inventing things like that. I showed Frank one day. Frank did another thing. He was, since Professor William Tiller, former head of the Material Sciences Department at Stanford, was also connected with that project with what was formed then as Astron Corporation. Professor Tiller knew a great deal about the magnetic vector potential A, which of course we didn't. And Frank thought so much of that that he decided he would build some A potential antennas, which he did. It was interesting because the CB radio was just coming into vogue, and all the truck drivers had them. You know, they started the vogue because they were chatting to each other and all. And Frank would take a CB radio and hook up his special magnetic vector potential antenna, and the little radio that's supposed to give you about a mile down the road would knock their socks off about 20 miles down the road. And these truck drivers would say, man, what have you got? What kind of rig have you got there, you know? But we knew we were onto something when the antenna performed so admirably. But Frank did build a whole series of special antennas, which some of those, plus some other modifications to them, Astron markets to this day. Astron Corporation still exists. I still own some stock in it. But I was fortunate to be able to work with Frank, because here I was able to work with an inventor where phenomenology was occurring. I was able to see some of the phenomenology and then have to figure out what on earth is going on here. So, in the injection of some real good science from Bill Tiller was nice too, because that put our feet in the proper scientific direction rather than wandering off and trying to form a lexicon of our own. We found out this stuff is really in physics, you know, if you know where to look, if you look long enough.
And that is carried through to this day.
That's right. So another thing, I was very fortunate to work with several other inventors that we've named, you know, such as Floyd Sweet, 2 or 3 others along the way, particularly John Bearden. I work with John today and have worked with him for many years. John, as far as I'm concerned, is probably the single most creative inventor on this planet. And he is what I consider a national asset of inestimable value for what he's already done. So someday the textbooks will be written on what Bearden has really done. It will curl your hair. So that was another great experience, to be able to work all these years with John and actually see things that produced very strange phenomenology electrically on the bench. But see John work out how to make them work. That was the missing ingredient. See, those are other people's discoveries. They are Golden's discoveries, or John Bearden's discoveries, or Floyd Sweet's discovery. I didn't discover any of that. My job was to work with them and then to sincerely do my best to find out what kind of physics would describe at least pretty close to what was going on.
Because they knew they had it, it worked.
They knew it, but they didn't know what the physics was. They had it working, and they had, by trial and error, found out how to make it work. Then the question is, how do you explain it? And my job was to find what kind of physics that thing is using. It's not a simple job, because often you can't do that in 6 weeks. It may take 6 years. But if you stay with it, and if you get enough phenomenology, gradually you start to narrow in the process. You accumulate a lot of references that you finally muddled your way through. You accumulate a lot of things that got actually discovered and parked on the bench nobody did much with, and you find out that's what is being done here. So you get slowly, you just narrow in to where you have at least a sort of a decent understanding of what's going on. It isn't perfect, but at least you have a proper physics type approach to what's going on. It can be put in very solid physics, for example.
And what's important about that? What's important about knowing how that, why, and how?
What's important about knowing something of the real physics of it is this. Many inventors have actually done some remarkable things. Stubblefield was certainly remarkable in what he did. Before Tesla got some of his stuff from Stubblefield. And it turned him on to the area. Then Tesla, of course, was a creative genius. But many of the inventors, the physics wasn't born yet, the early inventors that did this, to explain it. The physics wasn't available. So they created their own lexicon, their own terms, their own concepts. And what we have today, there's no way to translate that into physics unless you dig out the physics first. Well, if nobody's ever put together the bits and pieces to make a physics that you could translate to, it never gets translated. It's a chicken or egg situation. So my job was to tackle the chicken or egg situation, so that we wind up with a chicken and an egg. If you do that and you have some physics where you can now start to design, you now start to have a technology that can be built and developed and placed on the market eventually, and actually go out and be used to power homes and things like that. Until you get both some kind of theory that's workable, some kind of theoretical model that understands and fits this experimental phenomenology to help you with your design of then bigger systems, better systems, more stable systems, you're never going to have a technology.
Can't advance.
It can advance past the early prototype stage or lab bench experiment stage. Those who made it past there, like Ed Gray, went into production on a system. And of course, they came in and stopped his production line in Los Angeles, or you'd have had Gray systems on the market. So a lot of it was suppressed all the way, and that's very true. T. Henry Moray was absolutely genuine. All his systems were genuine. He had a 50 kilowatt system. But the vested interest came into play. No matter what you like to think, or whether you didn't want to be a conspiracy buff or not, I'm trying to remember the noted writer who said, it's not that there's one conspiracy, there are many, because every big organization's got all kinds of conspiracies going on in it anyway. That's the human situation. That's the 9% that try to manipulate everything. So don't worry about conspiracies. In every big organization, big group, or whatever, including big commercial companies after the Enron scandal, who do we have to convince of that? In every one of those big businesses, you have exactly the thing going on today. Well, people who early on took over power companies and things like that, and the power industry and all, and got the money for it, when you get through all the interlocking corporations, they really don't want to see that change, because that's the golden avenue that pours money into their coffers. It's just a matter of, I don't want to disturb my income.
You have the equivalent of 3 master's degrees.
Well, if you count the military training in Command General Staff College, that's considered the equivalent of a master's degree in military science. And in fact, you can get a formal master's degree there now if you do a thesis. I did a staff study, not a thesis, so I didn't get a formal master's degree, but it's recognized at the master's level in military science. And so I had that, and I had the actual master's degree in nuclear engineering, the equivalent master's degree in of a master's degree in aerospace engineering, and lots of missile experience. Lots of missile experience. So that's basically the background. We did go on later one day to acquire a doctorate. It's not a doctorate like you would get if you went to MIT. I got it for life experience. And I did submit a thesis. I did work on a thesis. My thesis was the first, hopefully legitimate, theory of permissible over-unity electrical power systems. And part of it was the first formal correction to Aristotelian logic, so far as I'm aware, that's ever been done. And the production of a 5-law logic, which turns out to agree very well with
Leighton.
well, it helps on latent stuff, but it also agrees very well with, I'm trying to think of the other fellow that did a beautiful work in logic that was very well indeed. It agrees with his logic's output entirely. So we came along the same path, you see, just a different track.
Pythagoras? No.
No, I'll think of it in a moment. But that was really what I had in my thesis. It was a correction to formal Aristotelian logic. You can show easily that all the methods we use to prove the logic symbols, logic theorems in 3-law logic are flawed. And when you correct it, you get a very strange logic. But it does seem to work in the real world. It does have some applications, but very strange, very odd. Yeah. Opposites can be identical because you inject the addition of observation. You don't really have A and not A. You have observed A and observed not A. You have applied a process before you can say you have A. Even in your thought process you have. If you take the process into account, you come up with a different kind of logic. See, Aristotelian logic never took into account the process. The closest thing to anything like that is the beautiful book, Mathematics, Loss of Certainty, that
Morris Klein.
That Klein did, Morris Klein did. And anybody that's interested in logic at all, I would highly recommend read Morris Klein's book.
You said something in the earlier tape from 2000. I played it for my wife, and it just fascinated me, and that is that it's a pretty simple concept, I suppose. We tend to look at everything in 3 dimensions, 3-dimensional space, because our minds exist in space-time.
That's right.
So can you say more?
We are fitted to the photon interaction, which is what generates what we call the 4 space, 3 space that we see. Because when you do observation, you do a partial with respect to t. You tear off the time dimension. You see a flat 3 space snapshot. And you see life like you do it very rapidly. You don't realize you're doing it that rapidly, but you never see the fourth dimension. You always see continuing series of three space